Hello everyone, myself Piyusha Shetgar. In today's session, we will see the topic Opamp configurations. This is the learning outcome for today's session. At the end of this session, students will be able to solve problems on different Opamp configurations. These are the contents. Now, before going to start today's session, let us pause video here for a second and recall that what is the closed loop voltage gain for inverting as well as for non-inverting amplifier. So, closed loop voltage gain for inverting amplifier is given by the equation AF equal to minus RF by R1, where AF is used for notation used for the closed loop voltage gain for inverting amplifier. It is given by the ratio of feedback resistor to the input resistor, and note that the gain is negative for inverting amplifier, whereas closed loop voltage gain for non-inverting amplifier is given by the equation 1 plus RF by R1. Now, let us discuss some points related to the different configurations of an op-amp. So, first is closed loop non-inverting amplifier. Let us define this non-inverting amplifier. In this configuration, signal is applied to non-inverting input terminal of the op-amp, whereas the feedback is given through the resistive network R1 and RF. This amplifier amplifies the input signal without inverting the input signal, because the input is applied to non-inverting terminal of the op-amp. This is the diagram for non-inverting amplifier circuit. So, if you observe, pin number 3, that is the non-inverting terminal, is given to the input, whereas the feedback is provided through this RI and RF network, which is connected to pin number 2, that is inverting terminal, and at the output load resistor is connected. Now, what is closed loop inverting amplifier? So, in this configuration, the signal is applied to the inverting input terminal and the feedback is given through the resistive network RI and RF. Again, in this configuration also, the output is amplified output of the input signal. So, here if you refer this figure, the input is applied to the inverting terminal, that is negative terminal at pin number 2, whereas the pin number 3 is grounded, non-inverting terminal is grounded, and the feedback is provided through the resistive network formed by this RI and RF combination. Now, let us discuss the voltage follower circuit. In voltage follower circuit, the output follows the input. So, in this type of the configuration, the output voltage is equal to the input voltage, both in magnitude as well as in phase. Therefore, the gain for the voltage follower circuit is the unity gain equal to 1. So, this is the diagram for voltage follower circuit. So, non-inverting terminal is applied to the input, whereas the output is fed back to the input side through the inverting terminal, and the load resistor is connected at the output. Output is taken at pin number 6 of an op-amp. So, this is voltage follower circuit. Now, based on these all three configurations, let us discuss the problems on an op-amp configurations. So, the first problem is given as the op-amp used in inverting as well as the non-inverting mode with R1 equal to 2 kilo ohm, RF equal to 100 kilo ohm, and the supply voltages are given as a plus minus 15 volt, and RMS input voltage Vi equal to 20 millivolt is given, and here we have to find out the output voltage for each case, that is inverting as well as for the non-inverting configuration. Now, let us discuss the first point. The solution is, the first is the output voltage for inverting mode. So, as we know that the inverting gain and non-inverting gain, by putting the given values in that equation, you can find out the output voltage for inverting as well as the non-inverting mode. Now these are the given quantities. So R1 and RF are given, whereas the supply voltages are given as a plus 15 volt and minus 15 volt, and the input voltage 20 millivolt is applied. So as we know that the feedback gain is given by the ratio of output by input voltage. So VO by VI. Now by using this equation, the output voltage can be written as AF times of the VI, where AF is the feedback gain, which is given by minus RF by R1. This gain is for the inverting mode. Now put that gain in the above equation of the Vout. So Vout equal to minus RF by R1 into Vi. So as you know that the RF value is given 100 kilo ohm, whereas the R1 is 2 kilo ohm. Put these values in this equation and Vi is equal to 20 millivolt is applied. So by putting these values and solve this equation, thus you are getting the Vout equal to minus 1 volt. So this is the output voltage for inverting mode. So as you observe this output voltage, you are getting this value is negative. So the input is applied to inverting terminal, therefore the output is inverted of the input signal. Now let us find out the output voltage for the non-inverting mode. Again you follow the same procedure. AF feedback gain is given by the ratio of V out by V in. So VO equal to AF times of VI. But here the non-inverting mode is there, therefore the feedback gain is given by the equation 1 plus RF by R1. So here this is the gain for non-inverting mode. Now put that non-inverting voltage gain in the above equation. So VO becomes 1 plus RF by R1 times of the VI. Put the values of RF and R1 and VI. So RF is feedback resistor 100 kilo ohm, R1 is 2 kilo ohm, whereas the input is 20 millivolt. So by solving this equation, so you are getting the value for the output voltage for non-inverting mode is 1.02 volt. Thus, if the resistances values are known to you and the input value is known to you, you can find out the output voltage for inverting as well as the non-inverting mode. Now let us discuss the problem number 2. In an inverting amplifier, R1 equal to 470 ohm, RF equal to 4.7 kilo ohm is given. If VCC equal to plus minus 15 volt, determine the value of the output voltage if the input is 1 volt peak to peak sine wave at 1 kilohertz. Also sketch the output waveforms. Now if you compare the previous problem, here in the second problem, the input is given as a sine wave, AC signal is applied here, and the mode of the amplifier is inverting amplifier is given, whereas the values of R1 and RF are also given, and the supply voltage generally equal to plus minus 15 volt is applied to pin number 7 and 4 of an 741 IC respectively. Now let us find out the output voltage for inverting amplifier. So the given are R1 and RF, R1 equal to 470 ohm, whereas the RF is 4.7 kilo ohm. Supply voltage is equal to plus minus 15 volt and the input is 1 volt peak to peak sine wave with the frequency equal to 1 kilohertz. Now again we know that this follow the same procedure as the previous one. The voltage gain is the ratio of V out by V in. So from this equation you can write the equation for the output voltage equal to AF times of the V in, where again inverting mode is given, therefore AF is equal to minus RF by R1. So put the value of minus RF by R1 in the above equation of the output voltage. VO equal to minus RF by R1 times of VI. Here RF equal to 4.7 kilo ohm, whereas R1 is 470 ohm, and VI is equal to 1 volt peak to peak sine wave is applied. Put these values in above equation, thus you are getting V out equal to minus 10 volt peak to peak. So here again if you compare the output voltage, here the output voltage is inverting, that is with the negative sign. Why? Because the inverting amplifier mode is applied here. Now you have to draw the input and output waveform for this. So, if you refer this figure, input and output waveforms, V in is equal to 1 volt peak to peak sine wave is applied with the 1 kilohertz frequency. Obviously, the amplifier gives you the output is in amplified form, but the V out is equal to minus 10 volt peak to peak. That means the output is inverted of the input signal. So, wherever, if you compare these two waveforms, wherever the positive wave is there, at the output it is inverting of the input wave is observed with the amplified output. So, here the 5 volt peak at the output side and minus 5 volt at this negative side. So, total minus 10 volt peak to peak is obtained at the output, that is at pin number 6. Now, let us discuss the problem number 3. In non-inverting amplifier, if R1 equal to 10 kilo ohm and closed loop gain of the amplifier is plus 5, find out the value of the feedback resistor. Now, here the gain of the amplifier is given, non-inverting mode is also given with one resistor value, input resistor equal to 10 kilo ohm is mentioned. Now, we have to find out the feedback resistor value RF. So, here the solution for the feedback resistor calculation, R1, RF, VCC, these values are R1 VCC's values are given along with the gain value equal to plus 5, and you have to find out the value for RF. In the above problem, non-inverting configuration is mentioned and the gain of the non-inverting configuration is given by 1 plus RF by R1. So, put the value of AF equal to 5, 1 plus RF is unknown value and R1 is given equal to 10 kilo ohm. Now, by putting these values and rearrange this equation to find out the value for the feedback resistor, RF is equal to 5 minus 1 into 10k, that is 4 into 10 kilo ohm. So, RF is equal to 40 kilo ohm. So, this is the value for the feedback resistor equal to 40 kilo ohm. So, thus we can find out the values of feedback resistor, input resistor or the gain or V out, output voltage for inverting, non-inverting as well as for the voltage follower circuit by using the above formulae. These are the references used for today's session. Thank you.